Hello there. My name is Andrew Schieltz, and today I'm going to be talking about a fairly new concept to the CM language called components. So, John Maltinsky and myself actually presented this in Orlando, but because of some technical difficulties, they weren't able to save the presentation, so I will be re-recording it right now. So, if it seems like I'm going through things pretty fast or I'm not stopping for questions, that's why, because I don't have an audience right now. I'm going to skip through the introduction because nobody cares at this point. So for core objects, if you look into the code, you'll notice that there are four primary subclasses of core objects. So you have animations and snappers. I'm hoping at this point you have a pretty good understanding of what these two concepts are, because if you don't, then getting into components is not going to be very helpful. So if you're not familiar with animations or snappers in particular, I'd recommend going out on the wiki and trying to find some more information on it or asking a configure developer. So again, you have animation snappers, and then you have vessels is the third one, which is new to about 8.5, I'm gonna say. They've done a couple different sessions on vessels in past conferences, so I'm hoping you have a little bit of introduction to vessels coming into this. But if you don't, that's okay too. And then you have this fourth core object that's fairly new called component, and that's what I'm going to be talking about today. So vessels and components, it's pretty easy to get these two concepts confused. They both have some similar traits. So they both can have core objects as owners. They can essentially support core objects that they then live on. Like I said, they're both used to support core objects, and both have the ability to drive graphics and properties to the core objects they support. Um, if you really wanted to, these two vessels and components, they're flexible enough to technically be used interchangeably. They have the capabilities to support other things similarly. So really the main difference between them is their design purpose. So components are designed to do this thing while vessels are designed to do this thing. So hopefully when we explain the use cases for components, you can kind of get an understanding of, okay, when should I use a component or when should I use a vessel. Um, so components, a component again is a core object. It essentially acts as a lightweight snapper. Paul put it best, I think, when he was explaining it to us. He said, think of it as a snapper minus the connectors. So again, components, they can drive graphics, they can drive properties and parts and a bunch of other different data to the core object that they live on. So components, by default, are stored on a core object's prop data. So, I mean, there are methods on core object to add components, remove components, access components, and all of those methods are um, defaultly handle this by storing and accessing the components on the prop data of the core object they live on. If you wanted to handle it differently for some other reason, you have the ability to overwrite these methods and store the components wherever you want to, but by default they are stored on prop data. So again, the difference between components and vessels are their use cases. So when comparing the two, there are two specific use cases that are for components. The first one is if you want to utilize similar objects across multiple snappers. So in the example that I have shown here, and I'll just jump over to code to kind of explain it a little bit better. So this is actually some Minmark product that we're showing you right now. We generally build, or we have a lot of casework cabinetry in our extension that is out here. So it's important whenever you build this cabinetry that you maintain your rack run. So you'll notice here that we have a little open space here that really it's not anything, but it's put in here so that way we can maintain connections between the cabinets that are on each side of it. So that way we can maintain this run. So we have this little open space here, and then in the corner we have a corner bracket. So it looks like a big corner cabinet, but you'll notice that really it's just these little panels in here that that mount to each side of the cabinet at the corner there to make sure that they stay connected. So anytime in our extension these snappers that act kind of as open space and you put a worktop on them, you need to make sure that you support the countertop correctly. So that's where we have these things called running supports right here. So they essentially just run right underneath the countertop to add a little support to this little open space here to make sure that the worktop doesn't like cave in, obviously. So as you can see, we have two different snappers here. This corner cabinet extends from corner rack. This little open space here extends from rect rack. So they have to be two different snappers. However, the running support that you put on both of them is exactly the same. The graphics are the same, the size is the same, the parts that they generate are all the same. So in previous solutions before components, we would have to essentially rebuild this object. So within this little corner bracket here, we had to build the functionality and the graphics and the parts for this running support. And then in this snapper class, we had to do the same thing. Well, obviously that's kind of inconvenient. It would be nice if we could just have one object for these running supports to be able to put across multiple snappers. So that's a good use case for a component. This is not the way that we have it built up, but that's the way, if we had to do it again, that this is how we would implement that. We would create this running support as a component and then have the component drive its own, property list and parts and graphics or whatnot. And then we would just put it on this snapper as well as that snapper. So you only code it once and you can put it across multiple snappers. So that's a good use case for components. The other use case for components is when you want to build a complex snapper into multiple pieces. So you see down here we have a what we call a cage bank. So this is another product that Minmark manufactures here. So you'll notice that we have 6 cages here. We have 2 bigger ones at the bottom and 4 across the top there that are a little bit smaller. So again, each one of these cages is pretty similar. There's a little bit of differences between them. Obviously, the width is bigger on your first row than it is on the second row there. You also notice that some of the cages have a little plastisol floors on the bottom. So whenever we developed this, we essentially built these cages into like kind of an I can't remember. It's like abstract component object or something like that. Anyway, something that essentially can take in primitive 3D and build a pick surface 3D on it, so that way they're selectable. And then the snapper itself just takes a collection of these classes and puts them together. This was a very customized solution that Configura wrote for us at the time because we did not have any better options. But now that components is here, you might be able to tell that, hey, maybe we could just build one of these cage sections as a component and then apply them across. So maybe this bottom row would be a snapper with two cage components on it, and you can customize each component so it can have a different width or it can have a different floor option. If I wanted to put the floor on the bottom here, for example, I think I clicked the base there. Yeah. So you can customize them a little bit, but at the same time, it could just be one object then. So again, this is another good use case for components. So those are the two primary ones that we think about, at least whenever we're trying to debate on whether or not to use a component or a vessel. So vessels, again, on the other hand, it's a core object. It provides feedback in modular construction to a core object or to space, actually. So again, vessels can be saved in 2 places. If you add a vessel to a core objects actually have a vessels field that lives on the core object, and that's where they get stored. They don't necessarily get stored in prop data, just like the components are. But you can also place vessels in space if you want. Space has a field called Vessel Manager that essentially you access that Vessel Manager and you throw the vessel into there, and then the Vessel Manager in Space itself actually handles putting in graphics or whatever you want from there. So those are the 2 places that you can store vessels. The best way to explain on when to use a vessel, if your use case doesn't call for building a component, then you probably want to build a vessel. So not that this statement is necessarily true, but I like to think of it as if I'm trying to build up a snapper, I like to use a component. If I try to build up an animation, I like to use a vessel generally. Again, that doesn't necessarily have to be true, but in my experience, that seems to have worked out a little, or that has seemed to be the trend for myself at least. So components, there's 2 primary component classes that you can consider at this point. Component, again, is a class that lives in core. that extends directly from core object. There's also another class called abstract component that extends directly off of component, and that has a couple more things that we'll talk about in the next slide. So abstract component is actually in the CM abstract component package. So if you're going to be referencing that, you will need to add that to your package declarations. So again, abstract component, it's a subclass of component, adds a little bit more functionality to the component class. The core object that the component lives on is actually saved on a parent field for further usage. So component itself, you can add a component to a core object, but the component class itself does not actually store that core object on its class. So if you'd like to add a component to a core object and you want to have access to that core object later on, um, if you extend from abstract component, you can just access the parent field and then you'll have access to that core object. Width, depth, and height fields are also available. And if they're set, the component's graphic or the component will actually build its own bound as long as you are using graph and primitive 3D for graphics. So that's really nice to not have to worry about building your own local bound. If you just set the W, D, and H fields on abstract component, then it'll build that bound automatically for you. And then there's a few more event methods that have been added. Nothing that I have personally used for anything, but they are out there. If you take a look at abstract component, it's really not that big of a class. So a couple of the things that they've built into there, you can take a look at it and see if it's anything you would ever want to use. Abstract component class is not actually an abstract class, even though the name would imply that it is. So if you want to use abstract component, but you don't really need to add much functionality to the class itself, which I can't think of a good reason why you wouldn't extend your own class off of abstract component. But if you just want to start using abstract component, it's not abstract, so you can actually instantiate it and then start using it if you'd like. Okay, so I'm going to start going into more of the functionalities of components. And to further explain some of these concepts, I'm going to be trying to implement them into an example here. So to lay out the example, we have an existing table snapper that needs to fulfill a couple of additional requirements that we've just been given. So the first requirement is we need to place 52 playing cards face down on the table. And when we click on the cards should turn over. So from the picture, you can see here that the cards are laid out here. This is what we eventually want to get to, and you can see that it has the little configure back to them. Whenever I click it, I want to be able to flip it over and see, Jack of clubs or ace of diamonds or whatever. So that is the first requirement. And then the second requirement is we need to place a case to hold the cards on the table. So this card case should be available in three materials: plastic, silver, and gold. And each material should drive an additional price to the drawing. So $10 for plastic, $30 for silver, or $50 for gold. So the following code, it's available in the dev conference repo that I'm hoping Paul gave you access to if you're listening to this. This code in particular, it's in the component sub package in the October 2019 package in the dev conference repo. I just put it in version 10.0 branch, and all the solutions will be out there at this point for you to go look at. So if you want to follow along or you want to see what I'm doing at the end of this, then feel free to access that code. It is out there for you. So constructing components, components have three constructors. So the first one is just a blank constructor. This is pretty common. If you need quick access to a field or a method in a component class for whatever, if you create your own component and you store some specific data in there and you want to quickly access it for whatever reason somewhere else in the code, you can just use this blank constructor and go get what you need and then move on. But if you're actually going to be using components, I recommend you use one of the other two constructors. So the first constructor takes in a key, active, and args. So key is an identifier that's pretty common with most things again. So if you just want to be able to identify your constructor after the fact, you can pass in a key, and then you have access to whatever that key is later on. Active is whether or not the component should start active or not. So if a component is inactive, it can live on the core object, but it won't like drive graphics or properties or parts or anything like that. So if for whatever reason you want to store it on a core object, but you're not actually ready to use it, you can set this to false and it will essentially turn it off, even though it continues to live on the core object. And then args is just a stringed object map. So components, again, extend from core object, which extends from prop object, which means that you can store prop data on it. So if there's any prop data that you wish to add to the component before you even get started with it, you can create your own stringed object map, add your argument or add your prop data, and then pass it into the constructor, and then that constructor will have access to that prop data later on. So the third constructor uses the same three arguments, and then it also adds a fourth one called object. So object is the core object the component should be added to. So if you know ahead of time as you're constructing that I'm constructing this component and I want it to go on this core object, you can simply pass in the core object and it will add it for you. So with that, there's two different ways to add a component. The first way, as I just said, is to pass the core object into the constructor of the component that will add it. Or if you don't want to do that right off the bat and you want to do that later, there is an add component method where all you have to do is pass in the component as an argument and then it should add it to the core object. I will say in my experience, if I've ever tried to add a component using the add component method, that I have sometimes had some issues getting the graphics to show up right away. If it's a caching issue or if it's a bug, I don't quite know. I'm sure there's a way around it, but I just never really felt like investing that much time into it because generally whenever I construct the component, I know exactly what core object it needs to go on. So I just pass it into the constructor and it seems to work fine from there. So if you know right off the bat what core object you want to add the component to, I would recommend just passing it into the constructor and moving on. But again, add component is another option if that's not feasible at the time you construct the component. So to remove a component from a core object, there's two different remove component methods. The first one takes in a key and the second one takes in the component. So if you don't have access to the component, but you know exactly what key of the component you're trying to remove is, you can just pass in the key and it will loop through all of your components on your core object and it will remove it at that point. But if you have access to the component as you're trying to call remove component, you can simply just pass it in, and that, if anything, that's easier, I think, to remove it. So that's what I prefer to do, but either way is fine. So we will go to code at this point and go through some of these, or try to add those cards, which was the first requirement that we had there. So we have just the simple table snapper, and we have a quick property on here for playing cards. So whenever we check this, we want the cards to populate on the table at that point, as well as the card case, but we'll get to that. So we have a property here, the table snapper. This property on the table snapper is using G2 properties. So we will go into the code here in table snapper, and we will go to quick property changed. So the key for that quick property is cards on table here. So we're saying if the value is a Boolean, which it is, then if it's true, we need to add the case and the card components. And if it's false, then we need to remove it. So we will get into that here. So to save on some time, I created a method already that that will build up a deck of cards for you. So what this method takes is a character to enum map, or sorry, tuple. So the first value in the tuple is character, so that's going to be the value of your card. So if you have the Jack of Clubs, for example, your character is going to be J, and card suit is an enum that I created. That's just your suits, so that's your hearts, diamonds, clubs, and spades. So we will gather these cards. It's a collection of tuples. We'll call it deck, and I think all we have to do is call it new deck. So if that compiles, we now have a collection of cards or of values that we can turn into cards. So now we want to loop through all of the cards. So we're going to do for I in 1 to deck.count, which should hopefully be 52. And then once we get into this for loop, we want to get the value of each one of those cards. So we're going to do character to card suit tuple, card equals deck, and then we're going to access the deck based on value we are in the for loop, so I minus 1 there. So that should give us the card. And then at this point, we're ready to construct the card component. So for card component, I had to add a little bit to the constructor to be able to handle the value and the positioning to make sure that the right material is applied to the card and to make sure that it's placed appropriately on the table. So you'll notice in the constructor here that I added deck index, character value, and card suit in here, but the rest of the constructor is the same as you would see from component. So when we create this card component here, we're just going to do card component. I'm going to pass in I as the deck index to know where to place it on the table. We're going to pass in the value, so card dot v0, and then we're going to pass in the suit card dot v1. That's the second value of the tuple. And then we need a key. So I generally like to make the keys unique. I don't think you have to, but if you want to access it later, and if I just made this card, for example, there's ultimately going to be 52 of these components. So if card is the key for each one of them, and then I want to go grab a specific card later on, I can't at this point. So we're just going to do card and then append I, so they'll make it card 1, card 2, card 38, whatever. And then since I know that I want to put it on the table snapper, I'm just going to pass in this. So that is all I should need to do for cards. And then we also need to put the case on it, if you remember as well. So I created a case component class already. We only need one of these, so I'll just call it case because that's enough to identify it. And then again, I want to add this to the table as well. So we'll just pass in this, and that should add it. So this all compiles. We come into here. I click on the table, and I select the property here. And you'll notice the graphics aren't on there yet, but we're going to create that in a future slide there. So I wrote a script at the very bottom here to essentially go through space, grab me all the table snappers, and then we're going to try to count the number of components that got added just to prove that the components are there, even though they don't drive any graphics yet. So if I run this script, you'll see down here that I have 52 cards and 1 card case down here. So that is for adding components. Down here, whenever we uncheck it, we need to make sure that we remove the components at this point. So I don't think I've said it yet, but to access the components, there is a method on core object called components that is essentially just a collection of components. I think it's a sequence of components that you can access. So we'll do for C in components, and we want to say if the component is in card component or C is in case component, then we're just going to call remove component. And since we have access to the component, we're just going to pass that in as the argument. And then from there, that should compile. If I go uncheck my quick property now and I rerun my script, I should see 0 cards and 0 cases. So that is all it takes to add and remove components from a core object. So components have the ability, like I said before, to provide their own graphics to the core object it lives on. I added the components to the table snapper there, but you didn't actually see the graphics yet. The component will eventually have to add its own graphics. So to write graphics into component, if you want to add 2D graphics, you just need to overwrite the get 2D method and then set your, I think it's a G instance. It's a G instance that passes through that method. So you'll just have to return a G instance that contains all your graph objects for your 2D. And then for 3D, I actually recommend overriding the build 3D method. So build 3D is specific to abstract component. It's written into abstract components. So if you overwrite build 3D, it actually handles your caching for you. So as you'll eventually see, I draw the graphics for this component, but I don't cache it like I normally would with other snappers. And that's because I overwrote build 3D. Abstract components get 3D method actually calls build 3D and then caches it for you. So that way you don't have to worry about that. But if you want to handle your own caching for some reason, or you extend it directly from component instead of abstract component, you'll want to overwrite get 3D then. So the position and rotation can be set by overriding the pos and the rot methods. So the position of a component will default to the 0 point of the core object that it lives on. If you want to move it from there, you will simply have to overwrite either of these methods to move it at that point. You can also, if you know exactly that this component is only going to live on this core object and it's exactly going to be on this spot on that core object, you could technically write your 2D and 3D graphics to go straight to that position just from, get 2D or build 3D or whatever. But I generally recommend overriding the position and rotation methods to handle that anyways, because the second you have any variability later on, you'll probably want to have that code there. So I'll show a little bit of that here soon. Once the component graphics are built, all you have to do is call components 2D and components 3D from the core object to get the component graphics. So again, we had the components on the table snapper at one point, so now we just need to drive the graphics. So if I go into the card component class, you'll notice that I have already wrote some code into the build 3D method here. So essentially, it is just two box 3Ds. So the way that I handled drawing the card, because I need to be able to draw it face up and face down, I need to be able to see the value and the suit of the card as well as the card back if I want to hide it. So essentially, I just built that into two separate box 3Ds, one applying the face up material and one applying the face down material. So I have all of that here in build 3D. But then again, you'll notice that it didn't actually drive into the table snapper whenever we applied it. So that is where we need to go into the get 3D method of the table snapper here. And you'll notice that this is again a collection of primitive 3Ds, and I build the tabletop. I build all four of the legs, and now I just need to add the components. And to do that, all I have to do is append get components 3D, passing in the fetch environment 3D argument from the method in as a component. What was it again? Components 3D, not get. Yeah. Components. There we go. Okay, awesome. Okay, so if we go into the drawing here and now we try to apply the playing cards, you'll notice that the graphics actually do drive, but again, they will defaultly go to the 0 point of the core object it lives on. So this is the 0 point of the table snapper, and I draw it out like you tend to do whenever you're drawing all the graphics. So this is where it defaultly positions. So now if we go into the card component pause method, I have some crazy code here written to place them correctly. But just to prove my point, I return point right off the bat. So if I get rid of that call and I do the same thing with case component, and then reapply the property there, then they should apply across the table, as you can see. So pretty simple. Not anything that should be really different from what you're experiencing as far as drawing graphics should go. So component selection, one of the primary features of components is that they are selectable. So when does that come in handy? For starters, if you want components to handle their own properties, if you want to be able to select a certain part of your, table, for example, at this point, and you get a requirement like, hey, if I click a card, I want to flip it over, like we're eventually going to do, then it's really nice to be able to actually click on the component and have it drive its own custom logic. So that's really nice, and that's the second reason you would maybe want this to be selectable. If you want to do something special, with clicking a component, that's where you can do this. Something that I didn't know originally in the at the conference, somebody made the point of it is that components are only selectable in 3D. So what makes it selectable, and this is even true with snappers, is that the snapper itself is not selectable when it's in space, but snappers build a pick surface 3D object based on the primitive 3D model that you build in your snapper, and that pick surface 3D is actually what is selectable. So that is a very 3D concept, and that is why components are only selectable in 3D. Um, so if you want to perform your own special actions on selection, all you have to do is overwrite the selected method from the component class and put whatever custom code you want in there. Sometimes, especially if you're trying to build up if you're trying to build a component that's going to be used across multiple snappers, and that's the reason you built it, so like the running supports that I explained in the beginning there, um, it's something that I want to share across multiple snappers, but they don't necessarily have to do anything special. If I click them, I don't want custom actions, or I don't want any properties or whatever. I don't really want them to be selectable. So if you don't want to make a component selectable, you can simply overwrite the selectable method on the component and just return false instead of true. So again, one of the requirements that we had was if I click on the card, I want it to flip over. So you'll see here that I can actually select that card in particular, but nothing happens yet. So again, if I go to the card component class and I overwrite the selected method here, I can do whatever I want on click. So again, as I explained in the build 3D method, I'd build the top half of the card and the bottom half of the card with a different material. And you'll notice whatever is on top is triggered by this face down field. So when face down is true, then you'll be able to see the configura back, and if face down is false, you want to see the actual value of the card. So in here, really all I need to do is swap the value of that field. So I'll do face down equals not face down, and then I'm going to invalidate the component as well as the parent. So again, this is nice to have the parent. So the parent in this case is the table snapper. So if you want to have access to that, if I had extended from component, I would not have this ability. But since I extended from abstract component, I do have this ability. So now if I go into the drawing here and I click on this, you'll notice that the card flips over. And if I click it again, it will flip over again. So I can just do that with all of these if I really want to. So that fulfills that requirement. Real simple stuff. Okay, components can implement their own properties when they are selected. By default, components use the new G2 property logic. In fact, I don't think build quick properties method is even on components. So the only way that you can possibly get properties from a component is using the new G2 property logic. One of the biggest concerns that we had starting out when we first used component is that most of the properties that we have in Minmark, or most of the snappers that we have in Minmark, use a custom kitchen property class. And we were worried that if we tried to put a component on a snapper that didn't use G2 property logic as well, that it would not work. This is not the case. You can put components on any kind of snapper that implements properties in any way, and you will simply just be using the G2 property logic from the component. But there will be no issues using component properties on a snapper that implements properties differently. So should be no worries there. So one of the requirements that we originally had here is this little card case right here. You wanted to be able to switch the material of it to be either plastic, silver, or gold. And in preparing for this beforehand, I thought the property was dead. It appears to be working because I never got rid of it. Okay, cool. All right, it's my bad. So anyway, in the case component here, if we wanted to build that property to be able to swap between your plastic, silver, or gold material, you essentially just provide your key in here, and then you provide your domain. So I had created an enum called case material that just has your plastic, silver, and gold values in here. So the property is an enum subset of those materials, and then you just build your prop input setting from the setting argument here. So we gave it a label of material as you saw, and then we just wanted to make it a quick property. So passed in the quick tag as an attribute for the property. And then in prop change down here, so whenever that value changes, really all we have to do is call and validate on the component. So when the key is equal to material, we are going to invalidate the component. And then whenever we click back on this, if I swap through the values, you should see the color change at that point. Yep. So again, real easy. Nothing too crazy there. Nothing you shouldn't have had a little exposure to. So components can drive their own parts. So this is another big differentiator between components and vessels. Not to say that you can't get parts from a vessel, but components actually have parts logic built in, and core objects have the ability to easily get parts from components. So if you're trying to debate on whether or not to use a component or a vessel, and there's the need for parts, you're probably going to want to lean towards component. Um, so to drive parts from a component, you simply need to add code to the getParts method on the component and on the core object the component lives on. So from the component, from the getParts method in the component class, you just need to add parts to the parts environment argument that gets passed in through the argument. And then you need to call the getComponentParts method from the core object and pass in the parts environment um, into that method. So remember again, the final requirement I think at this point was we needed to be able to price the material. So you see up here right now we have $0, but really if I'm plastic I should be $10. If I'm silver I should be 30, and if I'm gold I should be 50. So if we go into the code at this point and we go into the case component, which I'm already here, we have this getParts method again. So we need to add a part for this. So we're going to say if snapper is equal to parent, because whenever you pass in a part to that part's environment, the first argument you take in is your snapper. So again, another really good use case for having the parent accessible from the abstract components class. So we'll pass in snapper, and then you need to pass in the part number, description, and list price. And I just have those out. These methods already created to save us some time. So I'll pass in the number, the description, and the list price. That's all I have to do for the component. And then in the core object itself here in Table Snapper, all I have to do is call get component parts. And I need to pass in that parts environment up top there. So what get component parts actually does is it instantiates this component parts visitor, and the visitor itself actually takes in that parts environment. So if you're not familiar with visitors, it's essentially a way for a core object to visit other core objects. We instantiate this component parts visitor and we say, hey, here's the parts environment. Once we give that to you, go around to all the components on myself and go visit the accept method essentially on that component. So you have it here, and then you call visit all components. So what that does again is it goes to each component and it hits the accept method, and then from there the component's accept method says, hey, you're a component parts visitor. You're going to want to be passed to the getParts method on myself here. So it will come in here, pass in the parts environment from the core object that lives on, and it says, hey, do you want to add any parts? And here we're saying, yep, we want to create this part and we want to add it to the environment for you to pass back to the core object. So that way, whenever the calculation view comes around to collect the parts from the snapper, it can actually get it from the component. So once that all compiles, I think all we should have to do at this point is do a refresh, and you should see up here that we have a $10 part. And if I go to silver, it's $30, and if I go to gold, it's $50. And the part will actually generate as a line item in the bill of materials for you there. So not too hard to implement that either. So that's components for the most part. There's some other functionality, but that seemed to be the quick hitters that we wanted to focus on. So I wanted to make one note about a limitation of components. So if you choose to use CMSIM to build your components graphics, you lose the ability for it to be selectable. And the reason for that is because the default component logic uses the primitive 3D to build the pick surface that makes the component selectable. So again, I already explained that when you click on an object, you're actually clicking on the pick surface 3D that snapper or that core object generates. So for whatever reason with components, whenever you click this, that pick surface 3D doesn't get generated because it's trying to find a primitive 3D object that you obviously didn't create because you use CMSIM. So there's probably a way to work around it if you really wanted to. I tried for about an hour to try to figure it out when I was preparing for this, and I felt like I got close, but then I kind of didn't really feel like working on it that much more because I don't think a lot of people use CMSIM. I like it personally. We're trying to use it a little bit more, but we're not 100% on the CMSIM train yet either. So it's, whenever we run into these kind of hiccups, it's like, okay, we're just gonna start using or we're gonna use the primitive 3Ds again. So. If CMSIM ever takes off, this will probably eventually be addressed. Again, I hope it does because I do like CMSIM. I like the implementation. I really hate drawing my 3D and 2D graphics separately. So CMSIM giving you the ability to draw them at the same time is really nice. And I hope that it gets a little bit more stable, and I hope it takes off. And if it ever does, then this issue will probably be addressed. But just know that it is a limitation in the interim. So that is pretty much all we have. In conclusion, components, they're a pretty powerful tool. They add some cleanliness and extensibility. Configure developers are beginning to use it more often. We're trying to use it more often as well. We've kind of contemplated some crazy ideas of maybe just building a component snapper that essentially just acts as a carrier of components. We've had some ideas like that, have not got to the point of actually committing to that or implementing those, but it would not surprise me if we got to that. We got there at some point in the future. If you are working in the material handling industry, Eric Hinkle is currently in the process of writing a new abstract component class for you guys. So if anybody from Dematic's listening to this, stay tuned for that. Um, with that, I think that is all I have. So thank you for listening, and